Hi, in this video we're going to learn how to solve problem 1.2 in the Griffiths and Shroeter Introduction to Quantum Mechanics 3rd edition. Problem 1.2a asks us to find the standard deviation given this probability density. And this problem describes how an object is falling from a distance 0 to a distance h. And when the author says that there are a million photographs taken, that pretty much just means that it's a continuous function where every photograph documents the position of the particle. And this probability density is shown here in this graph. It is a square root decaying function since the square root is in the denominator. And intuitively, this makes sense because the probability that a photograph will be taken at a distance closer to when it was dropped is higher because the velocity of that object is less versus when the distance of the object is very close to being at h, which means it's very fast. That means the probability that the photograph will be picked at random will be lower, which is why the probability density here is lower. And that is also why this function is bounded from 0 to h in the x, and x represents the distance the object has traveled. And the lower limit of the probability density will be what this function will be when we plug in h. And when we plug in h, this becomes h squared. The square root of h squared is just h, so it's going to be 1 over 2h right here. That's the right bound of this function, and the left bound is that the probability density will go up to infinity as it goes near 0, since the denominator will get very, very small, which means that the probability density will get very, very big. So in order to find the standard deviation, the equation is the square root of the expectation value of x squared minus the square of the expectation value of x. So what we could do first is find the expectation value of x, which is just the integral from negative infinity to infinity of x probability density dx. But since we know that this function is bounded from 0 to h, we could change these intervals from 0 to h, and then we could plug in p of x we take the parts of the function that are not a function of x, which is 1 over 2 square root of h, and then this will be x 1/2 dx. So that means the integral will be x 3 over 2 over 3 over 2. These 2's will cancel, and then now we just compute the value from 0 to h. We don't have to worry about the initial point since the initial point is 0 and this entire thing will be 0, so we just have to plug in h, which is the final point. When we plug in h, it's going to be h over 3. Okay, now we have to find the expectation value of x squared, which is the same thing as before, except now we have x squared instead of x, same bounds. And once again, we don't have to worry about the initial point since it's 0. We just worry about h. And when we plug in h, we get h squared over 5. So we have now found both the expectation value of x squared and the expectation value of x. And we just need to plug in to the standard deviation equation. And we multiply this term by 9 on the top and bottom, and this term by 5 on the top and bottom, so that we could combine them. Then when we multiply on the bottom, it becomes 45. And ultimately, this is 4 over 45 times h, which is around 0.3 h. So the standard deviation is around 0.3 h. We finished question 1.2a. Now for question 1.2b, it asks us to find the probability of finding the particle outside of the standard deviation. We know that the expectation value of x is h over 3, so it's 1/3 of the way to h. We'll just say it's somewhere here. And we know that the standard deviation is 0.3 h. So on the left, it will be very close to 0, since 0.3 is very close to 1/3 h. And on the right, it's going to be somewhere around here. So this will be h over 3 plus 0.3 h. Then this will be h over 3 minus 0.3 h. And in order to find the probability of picking a random photo outside of the standard deviation, we have to take the integral in these portions of the graph. So from 0 to the leftward boundary of the standard deviation, and then from the rightward boundary of the standard deviation to h. So these will be the bounds of our integrals that we will take. We know the bounds of the first integral must be from 0 to h over 3 minus 0.3 h of the probability density. And we know that the second integral must be from the rightward bound of the standard deviation to h with the probability density. And then we just compute like normal now. And we know that the integral of both of these will come out to 2 square root of h x to the 1/2, and then 1/2 on the bottom is because we have to bring x to the top, and it'll be x to the negative 1/2 on the top, and then we take the integral from there. These 2's will cancel. And then we eventually get square root of x over h. And then this one will be 0 to h over 3 minus 0.3 h. And the next one will be x over h from h over 3 plus 0.3 h to h. And then when we plug all of these in, we don't have to worry about the initial since it's 0 here. H over 3 minus 0.3h over h, and then plus square root of h over h minus h over 3 plus 0.3h over h. And luckily all the h's cancel out. And what we get is every time we see a 1/3, we'll just assume that it's 0.33 repeating. So we get here 0.03 repeating plus 1 minus 0.63 repeating. And ultimately the probability will come out to 0.39. So this means that there's around a 40% chance that a photograph picked at random will be outside of the bounds of the standard deviation, so in the yellow regions of this graph. Okay, I hope this video helps. If there are any questions, feel free to leave it in the comments. Thank you.